Okay, here we go again. We have just finished grading the third homework. We had the usual people and then one more person having done the homework. It's very welcome to have new people enter. So what we're going to do now is first we're going to check that the results are correctly reflected in the list. So everybody, if you did the homework, I really need you to go to the list here. I need you to check that you have the amount of points corresponding to whatever you got in the homework plus the little questions you have answered. At this point, you should be able to have a 5-5-5 if you participated in all of the programming tasks. There's one person already getting ahead, which is very good. If you don't have at least 3, please ask for help showing us what you've done and what the problem is on the channel so we can help you. The exercise 1 and 3, those are really easy because those are just printouts. So you just copy the code, you put it in a compiler or online GDB, you substitute the values, you run, and you get the points. So there's absolutely no reason not to have those points. And starting today, we should start getting points in the E4 as well. The E4 is going to, again, have 3 mini questions, but the programming part is going to have twice as many points. It's going to be a maximum of 4. So now 4 is only going to be if you did what I requested. If there's something missing, it's going to be a 3 or less. Okay, and before we get to the what are we going to do in the exercise for chapter 4, we are going to visit chapter 4 a tiny bit. I already posted on the channel before the contents for chapter 4. So chapter 4 is about functions, also known as subroutines. And that's what we're going to be doing today. And much of the information is kind of like background information for you to understand what's going on in your computer. And I'm having faith that you guys are going to read it promptly at some point. But we're going to focus in a couple of particular things. Let us just browse through the chapter to make sure we're not missing out on anything. So functions are a way to create smaller functional elements within your code. And that's especially useful if you need to reuse the same kind of logic in different parts of the program. We already saw this in chapter 1, and we've already used this in our homework too. So we can define a routine. We need to say to the program, what's the value we're going to produce as a result? It's going to be void if there is none. And then what are the parameters? What's the information we're going to provide to the function? And it's important to remember that the function is actually getting copies of stuff like integers. It's not getting the variable. It cannot modify the variable. It's a copy. In a later chapter after the midterm, we're going to learn the concept of pointers, and pointers will let you modify the original variable from within a subroutine. But the important thing here is to notice that on the page 69, we first declare the routines, and then we define what those routines are doing. And now we could start doing something really cool that's called header files. Going a little further away here to the section about the header files. Please read the one about external variables. It's very informative. In this course, I would recommend you to avoid using external variables. It's a thing you're going to need later on, but it's just going to make your life worse if you start doing it now. So let's try not to abuse external variables. Anything that doesn't really have to be an external variable, most of the times you can manage it in another way, especially after we learn pointers. So the first thing we're going to be learning today is header files. We could make a program that consists in more than one source code. So we could make several different C files. Then we could make a H file, which is the header file, that says what are the functions that we're actually going to be providing. So in order to do that, we're going to first modify in a much larger terminal. One of the things we did when we were working on the how you should have done the second homework. So let's go find it. Document GitHub C. Let's make sure that we are up to date. Let's go to chapter 2. And I remember us making example of how to do the homework. It's the HW demo, I think. Let's look at that. Yes, this one definitely has a subroutine. This one has one as well. So basically, we're going to make a combination of these two. So we remember that we used to have a routine that checks if a number is prime, and then we have a routine. Actually, I think we have both of those here. Yeah, we have all of that here in this file. So we're going to make a copy of this file, and we're going to place that copy into the chapter 4 part of the repository. So now what I'm going to do is I'm going to go to that file and I'm going to separate it into different source files like here to see how this works without us needing to learn new code. So the first thing we do is I take all of what's definitions. All of the definitions are going to go in the header file. So let's call it header.h for now. So that's just definitions, that's nothing else. And now since I took them away, I need to include that header file here. Since it's my header file and not a standard library, I'm not going to put it between the larger and smaller symbols. I'm going to put it between quotes. So, okay, so that's the first thing I can do. I can put the declarations into an H file. Let's see what I have to do when I compile. I will need to tell it that, hey, I have this file, and this is the file that I am trying to compile. I press tabulator again, and now it's doing 7 billion things. Okay, and it technically works. The more correct way would be to specifically, explicitly mention that, hey guys, I'm using this header file. Okay, so now I have the main routine here, and let's say I want to put the tools, the mylog2, bin digits, and prime and bits into somewhere else because I want to use them from another program too. So let's make a tools.c. They now live in tools.c, and I am going to rename the header file tools.h. It's usually a good idea that your header files have names that remind you of which code file do they go with. So now if we look at, did I close my Emacs? Yes, I did. What's in the homework 2 file? There is no declarations there anymore, and there is only a main routine. There is nothing else. So now if I try to compile it on its own, I have a problem. First of all, I'm trying to include a header that doesn't exist. Let's fix that because I changed the name. I have to change it in my code as well. So I called it tools. And now it says that, okay, I found the header, but I can't find bin digits, I can't find bits, and I can't find prime. So why can't you find them? It's because I haven't said where's the other part. Also, I have a problem that now I'm implicitly declaring a library function printf in there. And even if I include my tool header, I still get the warning. Why am I getting this warning? Because I have different files that have different scopes. So now this file here, which is where my main is, it has all of these include things, but it actually doesn't need them because it's not printing anything. It's not doing any of the math either. So where I need to take the stdio and the math, they actually need to go into the tools.c file because this is the one that is actually calling the ceiling function, the square root function, the log function, and the printf function. The other one isn't. So I need to make sure that any libraries that I'm including, I include them where I use them, not somewhere else, because these files don't inherit or copy in any way the includes that are present in other files. I do need to include the tools.h though, because I need to be able to promise that these functions exist somewhere. So let's see, if I compile this like this, we're almost fine. We're still using the true and the false. And the true and the false, they're defined in tools.h. So now I could go and put the tools.h in that other file. We're going to create a tiny problem here. So now if I take this tools.h and I include it in there, in tools.c, I'm actually going to include it twice. And it's not so bad here because I'm just redefining those same, no, not c.h, sorry. I'm just redefining those same 0 and 1. But in general, if I ended up like, let's say, including other stuff from here, I might get a problem. So what we could do is that we could check if true hasn't been defined, then we could do this stuff here. And then if true has been defined, then we actually don't want to do it. So now we need to figure out what's the syntax of a preprocessor header like this. I'm pretty sure it comes here. There is a soon. Here, file inclusion. So this section is going to explain all of that. So I can make an if and def something, then I can define it, and then I can make an end if. So I could say here that if true hasn't been defined yet, then it means that all of this stuff is still kind of missing, and I want to define it. If it's already been defined, then we're not going to redo this stuff again. So now I don't get any trouble, and I don't actually include it twice. Now you saw earlier that my computer was smart enough that if I didn't mention the header file, it still pulls it in, but I do have to mention it in my code. If I don't mention it in my code, if I take it away from here, I should get a problem. I get a problem because it's an implicit declaration. What I cannot possibly skip while I'm compiling are the C files. I have to mention all the C files, and any H files that the C files are referring to have to be located in the same directory so that my compiler actually finds them. Let me send these things to the repository. It's the homework 2 in the chapter 4. It's tools C and tools H, and the small cat is talking to me. So if you need more information on the if and def, which means if not defined, there's also an option if def. That's all explained here in the same chapter 4. In the section 4.11.3 comes the conditional inclusion, which is what I just now did. So please, please, please read this part too, so that you don't end up including several times the same exact thing. Sometimes it's harmless and sometimes it's just horribly bad. What we really need to be looking into today, because it might produce confusion, is the section 4.10, which is about recursion, meaning that I could make a subroutine that calls itself. So what does it mean that a subroutine calls anything at all? So let's go look here in the file that we were just modifying, the HW2. So here, when inside main, when I use the routine prime, this is a call. I am calling this function. I am calling this function, I'm calling this function, and I am calling this function from the main. I could also make a situation, if need be, where a function calls another function. Like my function prime, it's calling library functions for ceiling and square root. My routine for log is calling for the library routine log. And my bin digit is calling my function and the library function. So those are calls. So what we're going to make now is we're going to make a routine that calls itself. And we're going to use a very popular example for this. We're going to work with the Fibonacci sequence. The Fibonacci sequence is a recursively defined mathematical sequence I'm going to write here in the comments the definition of what it looks like, so it gets here same way. So F0 is defined to be 0. F1 is defined to be 1. These are both called the base case. Like these are constants, they never change. Otherwise, I can't type. Otherwise, for any n that's larger than 1, we will have that f of n is the sum of f n minus 1 and f n minus 2. So this is a recursive definition. It's a very bad idea to implement the Fibonacci sequence recursively. We're going to do it today because one of my students was trying to do it the other day, and I want to show why it's a bad idea. So we need to be able to print, but we don't need to be able to do much else. And I want to make a function. So the Fibonacci number, it's going to be an integer because it's a sum of two integers. I'm just going to call it f. So f of n, what's it going to be? If n is larger than 1, then I am going to return the sum of f n minus 1 and f n minus 2. In another case, well, for 0, I need to return 0, and for 1, I need to return 1. I'm going to make an else here, even though I don't actually mandatorily have to. We're just going to return n itself. So if I'm asked for f1, I'm going to get a 1. If I'm asked for f0, I'm going to get a 0. And now to see why is this bad, let's add a print. Computing f, and then the number that we're computing it for. So computing fn happens here. Okay, I'm going to make a main that's actually going to call this. Main is going to return a 0, doesn't matter what it returns. So let's call this. Let's, for example, call f5. So I want to calculate the fifth element of the Fibonacci sequence. So what's going to happen here? f5 is going to go in here. It's going to try to compute f5. To compute f5, I need f4 and f3. Then to compute f4, I need f3 and f2. To compute f3, I need f2 and f1, etc. Tesla, you have to shut up. I'm in class. You can't bother your brother. I have to go break up a cat fight. No, you can't do that. It's a no can do. You can't bother Nefer. It's forbidden. Do something else. Sorry about that. Okay, so let's compile this file. I've already broken something. Expected function body after function. Oh, because I wrote it like Python. Okay, and let's run it. So to get the f5, I need the 4 and the 3. To get the 3, I need the 2 and a 1. To get the 2, I need the 1 and a 0. So you guys can notice I'm calculating the same exact value a ton of times, but I actually do get the correct results. Let's find here, print here, the result that I want. That wasn't what I meant to do. I meant to compile. Oh, but I was compiling in the other window. Compile, run again. So it does the calculation. But now if I wanted to calculate something much further along, like let's say the 15, the repetitive nature of this, it gets very painful. I'm calculating the same exact stuff tons of times. So this is obviously not a good way to calculate the Fibonacci sequence, but I can calculate it and I get the right result. The good thing about this is that the code is very beautiful. It's extra beautiful. But unless I have something that optimizes the frequent calculation of the subprograms, then this is going to be a dumb idea. How could I do this without using recursion so that it wouldn't be such a dumb idea? Okay, so that's dumb. Why? Because we have redundant calculations. So that's going to be called dumb F now. And let's make a better one. Okay, so to make a better one, we could do front is 0, back is 1. Okay, now these are the elements 0 and 1. If I want the element n, then I would need to do repetitions here. So how many repetitions do I need to do? Let's make a variable to calculate the repetitions. Let's make a for loop. And the for, we're going to start from I equal to 2, because we already have the elements 0 and 1. We're calculating the element 2. We're going to keep calculating until we reach the element n. Now, to make sure that we don't have any off by 1 errors, we're going to use both the dumb one that we know is doing the right thing and then the smart one that's trying to do something else. So what are we going to have to do here? I would want, if the front and the back, let's look at the sequence. I want to make swaps there. So first I have the 0 and the 1. I need the front to be the 1 and the back to be the 0. I want to sum them to be a 1. Then I want to move them so that the 1 goes in the front and the 1's in the back, so I can get a 2. And then I want to move them again so that I have a 2 in the front and 3 in the 2 in the 1 in the front and 2 in the back, so I can get a 3. Then I want 2 in the front and 3 in the back, so I can get a 5. So if we were doing something like Python, we would just say that front and back would be substituted so that front becomes back and back becomes front plus back. But I can't do this in C. I can't do 2 substitutions at the same time, meaning that I just need to say that front's going to be back, and now I have a problem. I want then, after that, back to be front plus back. But I already modified the value of back, so now I ruined my math. So I need a temporary variable. Putting that, let's put in temporary what was originally in back, so that we can put what was in, no, actually what was in front. So we can put back in front. Then we're going to take temp and we're going to add it into back to get the new back, because I actually need to add the front there. So now since I'm adding temp to back, I could just use an abbreviated notation to it. And this should be doing the correct calculation so that when we're done with all of these steps, back is going to contain the last sum. So back should be containing the number that we wanted. Now let's see if I have an off by 1. Oh, yeah, I have to rename it here because it's now a dumb F and a dumb F, the recursive version. Okay, now it compiles. And I forgot to, I'm incrementing n, I'm not incrementing I, that's why I have an infinite loop. And we're gonna hide the redundant printing now. I'm gonna put an if debug, no, if def debug, then we're going to print this, and an end if. So that if I'm not debugging, I don't want to be looking at this stuff here. So I could put no declaration of debug, so that print's not going to enter. Okay, I am off by 1. I need to go up until n. N still needs to be done. Yes, of course, because I don't want to stop at n-1. I want to stop at n. Compiling, running. So now I have 2 ways of calculating it. And this one, it only calculates F2 once, F3 once, F4 once, F5 once. So this one isn't a dumb idea at all. This one is a smart idea for being an iterative routine that doesn't revisit. If we want to do a recursive version of something where the same sub-problem happens many times, then we need something that's called dynamic programming, which means that we need to be remembering the intermediate values. Like the first time we calculate F2, we just need to remember what's F2. And the next time we want F2, we should be checking what's the value that we already know for F2. So this is a thing that we can do with recursion, but we don't really win anything except elegance. The execution will be inefficient. But let's put it in the repository anyway. And then do another one where it's actually a good idea to be using recursion. Okay, another example where recursion is actually going to be very powerful. So let's say that I need to calculate the factorial of a number. The factorial of a number, it's denoted by n exclamation, meaning that it's going to be the product of 1 times 2 times 3 times 4 times whatever there is times n minus 1 times n. So now this is very suited for what we are doing. So I could make a factorial function. Let's print again so that we can see that this is actually not dumb and repetitive. So let's look at what number n we are at any given time. And now, what's our base case? Factorial of 1 is 1, but also factorial of 2 is 2. So we could just say that if we're calculating a factorial for something that's less than 3, it's going to be the number itself. Again, we're assuming that no one's dumb enough to try to do this with anything that isn't a positive integer. So we could put here that if n is smaller than 3, then we are returning n itself. This is the base case. If else is larger, if n is larger, what are we returning? We are returning n times the factorial of n minus 1, meaning I'm going the other way around here. I'm saying that to calculate the factorial of n, I'm going to multiply by n, whatever this is. And then whatever that is, that's going to be n minus 1 multiplying whatever this is. And it's eventually going to go all the way down to a factorial of 2. And we know that's 2, so we're going to be done. So this is also very elegant and kind of brief. So let's make another main. And make the program print what the values of the factorial are. So the factorial of n is going to be fact n. Let's compile this one. Implicit declaration. Okay, I wrote factorial here and I wrote fact in the others. Okay, let's run this. So now the factorial of 5, it first visited 5, then 4, then 3, then 2, and then it knows the answer. So there is no redundancy. Meaning that I have now a program, I should have changed the number, that I could use to efficiently calculate factorials. Let's get the factorial of 8. That's 40,000 and then some. Okay, so here it's actually very useful to be able to write a recursive function. I could do it iteratively as well. Let's actually do that too, so you guys can compare it. I could do it with a for loop, just the same. It's not going to be much uglier or anything. I'm going to call it efact. I keep trying to write Python. First, the result, I'm going to put it as a 2. Then I'm going to make a 4, where E starts from 3, goes all the way to N, matching N. We need to increment I here, not the N. We're going to want to return the result. And we're going to want the result to be, actually we can make it with less code if we just start with 1. Because multiplying by 1 doesn't do any harm. So we just need to multiply whatever we have in the result by whatever the value of I is. So this goes the other way around. First it's 1, then it gets multiplied by 2, then it gets multiplied by 3, then by 4, and eventually it gets multiplied by N and it returns the result. Okay, so that's recursion. In the example code in the book, they're discussing a very good algorithm called quicksort, which orders an array. And I'm actually going to go to the whiteboard to show you guys how quicksort works, because if I just explain it to you, you are going to be seriously unhappy. So basically it says here, given an array, an element is chosen and then others are partitioned into 2 subsets, those less than the partition element and those equal, and the same process is applied recursively. So let's see what this looks like. Okay, so let's say I have my numbers here. I have a 13 and a 5 and a 21 and a 52 and an 81 and a 4 and a 25 and a 61. Let's say I want to sort these. So what I do first is I pick a number, any number. I'm going to pick the 52. Okay, nice, 52. Then I am going to create 2 little arrays, the ones that are smaller and the ones that are larger. So in the smaller one, I'm going to first put the 13. So these are going to be the smaller ones. X is smaller than 52. These are going to be the larger ones. So basically 13 goes here, 5 goes here, 21 goes here. 81 is going to go in the larger, 4 goes here, 25 goes here, and 61 goes here. The easiest way to understand this is imagining those 2 different arrays, but what we can do is we can swap these elements around to reaccommodate them, but I don't want to make you guys worried about that. So now if I want to order this part here, I'm going to grab a value again, let's like the 21, and then I'm going to make the smaller than 21 and the larger than 21. The smaller ones are going to be the 13 and the 5 and the 4, and the larger ones are going to be 25. When I only have one thing left, there's nothing to sort. So this one's already ready. I have to continue recursively with the 13, 5, and 4. Let's say I pick the 4. So then the smaller than 5, that's going to be the 4. I'm done, nothing else to do. The larger than 5, it's going to be the 13. I'm done, there's nothing else to do. So now this thing, I know it's going to be sorted as 4, 5, and 13 because it's the smaller, the one I chose, and the larger. And I know that this other one here is going to be sorted as a 25. So then it's going to be the 4, 5, 13 separated with the 21 from the 25. So now 1/2 is done. I have a recursive problem here. I need to choose one of these to be my split point. So smaller than 61, there's not going to be anything. Larger than 61, there's going to be the 81. So I'm going to end up with the pivot element first, and then the larger one. So now I know that because I was pivoting with a 52, the 52 has to go before all the small, after all the small ones and before the large ones. And the large ones are going to go the 61 and the 81 first. So I'm going to end up with a sorted array. So that's what quicksort does. And I would really recommend, if you've been comfortable with the previous homeworks, that you really pay attention to this part in the book, that you work out how does this code work, especially since this code isn't copying this stuff to other arrays. It's very cleverly moving things from one position to another to make sure that all the minor, like less than the pivots are going to be on the left side, and all the larger than pivots are going to be on the right side. So what I would recommend is with your notebook, kind of like working out little by little what this code is doing. But I'm not going to force everybody through it because you're going to be a little unhappy doing that. The exercise 413 is much easier for people who are like not very familiar with what's going on here, because what that's going to do is reversing a string. So making the letters of a word be in the opposite order, that's really easy to do recursively, because first you need to switch the first letter with the last letter. Then from whatever remains inside, you switch the first letter with the last letter. And from whatever remains inside, you switch the first with the last until you get to the middle. And when you get to the middle, if there's only one letter there, so you had an odd number of letters, you don't have to do anything. And if there's nothing left there because there was an even number of letters, you also don't have to do anything. So the base case is going to be a string length that's 1 or smaller. So that's a very good exercise. So if you feel that you've understood everything thus far, work with the quick sort. If you feel you're struggling, do the reverse function and don't really worry about the quick sort. And then next week, we are going to have a holiday. There's no class next week because of the Independence Day. The week after that, we're going to have the midterm exam. I'm going to show you guys again the midterm exam system in a little moment here. And when we come back, we're going to continue with chapter 5, pointers and arrays. And this is where a lot of people are going to start getting lost. So if you have any doubts, please reread chapters 1 to 4 as many times as you need in preparation for the exam, so that we have no questions whatsoever remaining about those topics when we come back, because it's going to get really nasty if you're confused. Let's make sure I have nothing here that I'm supposed to show to you guys. This is all old stuff, it doesn't matter. But I never pushed the last one, so let's push it to make sure that it's actually in the repository. Checking here and linking them on Discord so that you have the direct links to the one we were working today. So first, I was working with the homework 2. I made it into the tools C and tools H. After that, I made the Fibonacci example. And after that, I made the factorial example. And I'm requesting that people who are doing very well you can test if you're understood by studying the quicksort code. But if you're slightly confused, it's better to work with the exercise that's reversing the string to really understand these concepts. You're not going to be able to understand them just by listening to me. It's absolutely mandatory that you have to start writing code. Nobody learns programming by listening to other people. Everybody learns programming by programming. There is no way around it. So what are we doing in the mini exercises for chapter 4? The first thing we're going to do is a recursive function for computing the greatest common divisor. I'm going to show you this algorithm on the whiteboard, and the only thing you guys need to do is figure out what to put here. This is the base case, and you need to figure out what do we return if it's not the base case. Okay, so that's going to be just substituting an expression. And here, this one is a code that checks if a word is a palindrome. It's a very similar code that you would use for reversing a string, because a palindrome is a string that's equal to its reverse. It's a word that's like read in the same way, regardless of whether you start from the left or from the right. I'm also going to show you an example on the whiteboard. And in the third example, it's just a printout. So you're going to put the value of A, the value of B, then you're going to print it out, and you're going to make sure that you understand what's going on. So here I'm trying to make sure that you understand how the define if def is working. There isn't really much other to it. After the whiteboard stuff, we're going to talk about the homework. It's going to be much more demanding than the previous homework, but it's also going to give much more points. If you just do some partial parts, it's okay. This is also an exercise that the book will discuss. So if you read the book well, you're going to be fine. But let's go look at the greatest common divisor and the palindromes on the whiteboard. Okay, let me erase all this quick sort stuff. And let's start with palindromes. Those are much easier. So if you have a word like Anna, that it doesn't matter if you read in this order or in that order, that's going to be a palindrome. When you write a code for checking for that, what you really need to be doing is recursively just getting rid of letters. I'm going to give you a palindrome in my native language. This means soap salesman, vendedor de jabón. So to check whether that's a palindrome, remember there's going to be a string termination character here. We need to figure out the string length, like how many letters do we have, so that when we can look at the index 0 and the index length -1, we can notice that these are both letters S. So now what the recursion does here is, I know I don't have to look at those anymore. And now I'm going to look at the new first and the new last because I skipped them. After I skip those, I am going to look at the new first and the new last. And then I'm going to look at the new first and the new last. If I want to do this with a for loop, I actually need two integer indices. I have an I that starts in the beginning, a J that starts in the end, and I keep moving them both. But it's a little easier to understand it when it's a recursive call, because you simply say that if you have only 1 or 0 letters, then true, it's a palindrome. If you have more, you take a substring starting from index 1, ending in index length -2, and you return whether that is a palindrome. So that's going to be relatively easy. And then the other part that I promised to show you is the algorithm for the greatest common divisor. So what does this algorithm do? Let's say I need the greatest common divisor between 27 and a 5. I'm going to have a variable A that's going to contain the larger of the two numbers, a variable B that's going to contain the smaller, and then I'm going to put the residue as a result of each step. So the GCD of 27 and 5, I put here the 27 and 5. What do I need to calculate? The residue. If I divide 27 by 5, I'm going to have a 2 left over because 5 fits 5 times. That gives 25. 27 minus 25 is a 2. So what do I do next? I put the 5 in here and the 2 in here, and I repeat recursively. So from 5 and 2, 2 fits twice. I have a leftover of 1. Then I put the 2 here and the 1 here. The 1 will fit 2 times in the 2, and there's nothing left over. So whenever you see a 0 here, the result you're actually going to return will be whatever is in B. So just make a code that returns whatever is in B whenever the residue comes out 0, you're fine. And now if I made one more call here, it would be putting 1 here and 0 here. So now this is technically your base case. When you get called with A equal to 1 and B equal to 0, then you know that A is the result. So you can either stop by checking is the residue 0, or you can stop by checking is there a 1 here, or you could stop by checking if there a 1 in B, because there has to be either a 1 in A or a 1 in B. If you have a 1 in B, the result is the residue. If you have a 1 in A, the result is B. This is called the Euclidean algorithm. I'm going to get you guys a picture of it. But that should be a very easy point to get today. The printout point, it's obviously a free point. You just copy the code, so there's no reason not to have at least one point. So that's the palindrome, that's the GCD. And now we are going to look at the homework. We are going to make a calculator. So let's look at what the calculator needs to be doing. Really important you read the chapter. So it's going to be a reverse Polish notation calculator. I will Google that for you guys in a moment. It's going to be with integers. Don't worry about any other values. You're going to have variable names that are going to be single letters. So basically meaning that you could assign a value a equals 2. And we're not going to care if it's an uppercase or a lowercase. So uppercase a and lowercase a both should now return a 2. If you're trying to assign a value to a variable that already has a value, your program will give a warning and ask for confirmation. Unless the user, instead of writing, I'm going to write here in Discord, like the regular assignment is just going to use the equal sign. And if I'm forcing a rewrite on top of a variable that already exists, then I'm going to add a colon in front of the equal sign. And this means that there's not going to be any warning because I'm explicitly saying, I know I have an A and I want to change its value. And this calculator will keep on letting you calculate until you use an AOF. If you're worried about working with numbers like 122 or whatever, you don't have to. You could just make your input numbers be like single digits, like 0 to 9 if you want to. It's not impossible to work with larger variables, but if it's complicated for you, start working with just single digit variables and then extend it. So now what we're going to need to discuss is the reverse Polish notation. Let's first go to Wikipedia to understand what on earth is reverse Polish notation. So what do we have? We have a way of writing numbers. Let me copy the Wikipedia for you so you can read about it. Where we reorder the numbers and the operators in a more convenient way for computers. I'm going to copy the example from Wikipedia right here. So instead of writing 3 minus 4 plus 5, what we would type is 3, 4, then the minus, then a 5, and then a plus. Because the computer is going to read it like, hey, I was given a 3. Lovely. And now I was given a 4. Lovely. Now I was told to make a subtraction between them. So I'm going to do the subtraction of the 3 minus 4. And I'm going to know that now my value is going to be minus 1. Then it's going to be like, hey, here's a 5. So now I know, okay, I'm going to have to do something with minus 1 and 5. What do I have to do? Sum them. Okay, so I'm going to do minus 1 plus 5, and I am going to get as a result that this is going to be a 4. So like when you have a calculator like this, it doesn't need to remember a whole lot of things because it just needs to hold that I have this on my like left side of my operation, this on my right side, and I am going to operate with those. So let's try to find a tool that actually does this. It's helpful to have somewhere where you can test it. Okay, this guy just explains how to do it. I'm going to try to find a JavaScript one, so you guys have something to test against. Oh, this guy just does it. Okay, you can test it here. This is what I want. Oh God, I don't want to. I just want the calculator. Okay, free online RPN calculator. Great. Okay, how does this work? Okay, let's try this. So I want to do the stuff we did here in Wikipedia. I have a 3. Where do I write? 3. Oh my God, I have to click the buttons. 3. Okay, then I have an enter because that's my first number. Then I have a 4. And then with the 3 and the 4, no, this is okay. I think it's just the implementation. I want an interactive one that actually shows it. Every time I find one, they get rid of it. And this one's a PDF. But if I write it for you guys, then you guys don't want to write it anymore. Okay, this one should do. Just don't think about the JavaScript. So I should be able to write here 3, 4, and a minus. It gives a -1. Then the 5 and a plus. Okay. So this one is actually working. We can use this one. So now here it says assuming single mode. So it's expecting a single character, just like I said that in your homework, you just use single character variables if you wanted to. Okay, so basically you cannot do something like 12 times 5 because it's going to read it wrong. Because if you put the 1, 2, and then you try to put the 5 to do the times, it says uncaught extra operand because 3 numbers in a sequence doesn't do anything. But if I put the 1 and the 2 and then I put the plus, now it added them together, I have a 3. If I want to multiply that by 5, I put first the 5 and then I put the multiplication, I get the 15. If I want to divide that by 2, I would put first the 2 and then the division, and I get the 7.5. So there's 2 tasks here. First, become comfortable with the reverse Polish notation so that it doesn't hurt your brain when you have stuff like this. And if you really want to make it easier to read, imagine spaces in there. If you work with just single letter numbers as input, you don't need to imagine the spaces. But if you ever wanted to do something like 12 minus 5 plus 2, then you really need to imagine the spaces because you can't have the 3 numbers continuous. When you've understood the reverse Polish notation, then you will start designing your calculator. And to be able to store the values of the variables, since the variables are single letter variables for lowercase only, we could basically use the ASCII code of the letter as like an array index. And since we know that the uppercase A is a 65, if we just subtract the 65, then the index 0 could be A, index 1 could be B, index 2 could be C, and you have to do very little arithmetic to access those. So then your variables would simply need to be an array that's as long as the alphabet, so you can put the variables there. Then reading the input, you can just with getchar read them. Whenever you get a digit, you know that you're getting an operand. Whenever you get something that isn't a digit, you need to check whether it's a plus or a minus to figure out what's the math that you need to be doing. Remember to not use the character value of the digit because the 2 doesn't equal 2 in ASCII. But as like we've seen before, if you subtract from the ASCII 2 the ASCII 0, you can actually recover a 2. So that's going to be pretty easy to convert them into numbers. So you just need to remember that you need to have a variable that holds your left operand, a variable that holds your right operand. And then whenever you get the operator, you just do that math with those 2 values. And whatever you get as a result, That's going to be your new left operand, and you're waiting for input to give you a new right operand, and that's how you continue. So you're going to need cycles. You're going to need probably a switch case to deal with the different operations, and you might want to consider subroutines. For example, for storing the variable, consulting the variable, checking if a variable already exists. And you could even make subroutines for the sum, subtraction, multiplication, division if you wanted to. So try to design it first. And before you do a whole lot, try to tell on the Discord channel, what are you planning to do? So that if you have a horrible misunderstanding, I can intervene and I can tell you, no, 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 that's not what's supposed to be happening. You're making your life difficult. And I would like to talk to you about this. Just try to remember that when it's a holiday, I'm not necessarily connected either, but I am going to be checking Discord, usually most of Friday, Monday mornings, occasionally on Tuesdays. I'm on Discord pretty much all Wednesday. And I'm on Discord, but busy with classes pretty much all Thursday regularly. So I'm around very often if you need to ask any questions. So first, please, right now, before you disconnect, try to get at least 1 point in the mini questions of exercise 4, so that I know that you are here, you've actually understood something. When you have all the 3 mini questions already responded, then start learning the Polish notation. If you feel that you didn't really understand the concept of the chapter, then either study the quicksort or the string reversal before you try to do the more complex homework assignments. And then before you start programming, just make sure that you have actually understood what the reverse Polish notation means and how it operates, and that you can, with like a pencil and a paper, happily work it around. And when you're really comfortable with it, then you will start programming and you let me know. Anything that's able to read some values and do some math, you're going to get 1 or 2 points. If it's actually able to do a couple of calculations right in the reverse Polish notation, you're probably going to get 3 points. If it's actually a reverse Polish notation calculator that you programmed instead of copying it from somewhere, you're going to get the 4 points. Remember, if you suddenly start writing perfect code and you haven't done anything yet, I'm probably going to be a little suspicious and ask you some questions. So just try to make me happy. Get some points here in the column E4. You should be able to do that now, at least the one that just does the printout. I will give you guys the link to the Twitch stream. And if anybody has any questions right now, please go back to the voice channel. I will come with you and we can speak in the language that you are the most comfortable speaking. Voy a repetir esto en español. Si tienes cualquier duda, ven al channel de voz de Progra ahorita que yo termino la transmisión en Twitch para contestar cualquier duda que tú tengas. Recuerden que la semana que viene no hay clase por el Día de la Independencia y la semana después hay examen y nos toca examen miércoles. No va a ser jueves, va a ser miércoles. Oh, I forgot. I also wanted to show you guys the exam system. I already showed it last week, so you should already be able to practice it. I had a tiny bug last week, which I immediately fixed. So how do we go there? I click on the link for the exam. This has these instructions. It's very important you read the instructions. You're supposed to have a sheet of paper. You're supposed to have your credencial estudiantil. And no, it's not going to be your driver's license. It's not going to be your passport. That's the only thing I want, the student ID. If you don't have a physical one, usas la electrónica que está en CIASTE. Todo el mundo tiene acceso a eso. To enter the exam, you put your student ID. You put the same email you're using for the homework. This is going to be a practice session. On the day of the exam, you can send me your credentials so I can send you the PIN code to access. You will enter here. It's going to generate a new exam. Everybody has a different exam. Don't ask other people for their answers. It's a different exam. It's always the same code, but there's 20 pieces missing, and it's switching around which ones they are. So here it says that I need a library for printing. So that's stdio. I need a library for math. So that's math. And then I could just guess some stuff. It says that these are integers. These are really easy. There's some other integers somewhere that we haven't looked at yet. Oh, this is going to be a pointer to a character array. We haven't worked with the pointers a lot, but we have seen those because it's a character array. So it's going to have some name that we don't know yet. So we're going to find it out later here. But those are usually, they kind of look like this. Could also have an asterisk on it. Let's see if it likes the asterisk. Here we're clearly printing something. I put too many P's. Okay, it's asking for input and it's talking about digits and it's going to print this max. Okay, so now we know that this constant is going to be max because there's a max and it hasn't been defined yet. So since I'm printing an integer, I could do the percentage %d. Then we're looping max times, so I has to be incrementing. Then I need to know if whether it's between 0 and 9, so I need an AND. Then I am printing something. I'm not going to solve the entire exam for you, just some examples. Then I want to keep going on a do while. And here I want the length of a string, and the string is clearly called S. So now we also know that the string we're working with is going to be called S. And we're checking if the lowercase matches. Matching means that it's equal to something. And if I'm substituting something, it kind of means that I'm going to put it into the string. Then I'm dividing by 2. How do I divide by 2? I could remove the last 0. So why do I have an equal 1 here? Equal 1 here. Oh, because I wanna take 1 0 off. So I'm going to push to the right by 1 position. And then after I'm done, the button to grade is only going to be enabled when you've answered all 20. So you need to guess the ones you didn't know. In the real exam, you need to send me a picture of the notes you wrote on paper. You don't have to write the whole code, but you do need to write your answers. I will give you another pin code and you will grade. And it'll tell you immediately your result. So the ones that I was guessing, like the something and the stuff and the guess, those are incorrect. But all of the others are correct. You can practice as many times as you'd like. Okay? So if you're not certain, if it wants one option where there are actually 2 possible ones, just practice and you're going to learn which one it actually wants. It's not going to be a horrible, difficult thing. Just remember, there's going to be 2 different pin codes. Yo te doy la clave para entrar cuando tú me mandas foto de tu credencial o la electrónica o la física. Y te doy la clave para calificar cuando tú me mandes una foto de tus apuntes. Tiene que ser una sola hoja de papel y tiene que tener escrito tus 20 respuestas. No es necesario escribir todo el código. Any questions, come to the voice channel. I'm going to stop transmitting and I'm going to give you guys the link. Let's see if somebody's actually working here. Oh yeah, a couple of people are actually working on the homework, so that's nice. I have at least an audience of 2. Please ask for help if you need help. Don't suffer alone. I will catch you guys in a couple of weeks on a Wednesday when we have the exam. Remember, we're grading the homework, not the day of the exam. We can't grade anything that day. We're grading it when we come back. So that's a long time away. You have a long time to learn the Polish notation because after the exam, we're going to have 1 week with no class because that's the second week of the exams. So basically, if we want to know when's the next class, the next time we are grading anything is going to be in October. So you have until October 7th to figure out this reverse Polish notation stuff. So don't hyperventilate. You have a long time. But I'll see you guys on the 22nd for the exam.